Yes, check. Everyone, it's quarter after the hour, quarter after seven. Right, if I can have everyone's attention, please. Okay, good evening, everyone. I'd like to call this meeting to order, please. And my voice is again strong. Good evening, everyone. If I may please have your attention. It is quarter after seven, and it's time to call to order this month's meeting of the Madison Astronomical Society. My name's Lawrence Moore, and I'm the president of the society, and it's great to see you here, everyone. And I guess we can address the white elephant, or is it the white tables in the room? Some things have changed. This cable is not the best quality cable. Some things have changed since our last meeting last month. The UW Astronomy Department, good news. The good news first, they have opted to renew the lease for Space Place for another year. And we all know research organizations have budget pressures this year. I'm sorting out my source of noise here or something. So the bad news is that they did not keep the lease for the classroom. So now we've got all the tables that were in the classroom next door in this room. So we'll just try to see how things go this month, and we'll try to come up with a plan for next month. So I appreciate everyone's patience and understanding with the upheaval. Another thing that's coming up here that everyone might be interested in case after tonight's astronomy related presentation, you're just saying, "God, I haven't had enough astronomy related presentations for 1 week." If you come back here at UW Space Place this Tuesday on September 16th, the Amateur Radio Astronomy Club, who also meets here, is having a presentation called that has to do with amateur radio astronomy. Yes, the Four Lakes Amateur Radio Club is meeting at this base here this Tuesday, 7:30 p.m. And the featured speaker is Dennis Kidder, and he's going to discuss how you can get your feet wet with radio astronomy. Which sounds, I've had people bring up the topic. Hey, have you ever considered putting up a radio telescope out at YRS? Well, it'd be interesting to learn more about that topic. So be here again on Tuesday, 7:30 this week to get a presentation about amateur radio astronomy. Coming up real soon on September 20th, a week from tomorrow, is our annual picnic. And unless there's a rain issue or something, it'll be a week from Sunday. But a week from Saturday, we'll have our annual picnic, and cross our fingers, hopefully nighttime observing to follow. And I guess, Chris, did you want to share some information about that?
Yeah, the picnic starts at 3. It's out at YRS. I got a lot of mouth. People know that. The picnic starts at 3. It's out at YRS. The club provides water, brats, hot dogs, burgers, the condiments, the buns, that kind of thing. Everything else is potluck. This is a really good chance to get together and talk astronomy with everyone, get to know your fellow club members. And if the sky is clear, we stargaze. So hopefully I will see a lot of you there. I will be sending out an email in a day or two. I would like a rough head count of how many people are coming so I know how much food to buy. But keep your fingers crossed for good weather and we can all get together. Oh, and bring a chair. The other thing I'm thinking is, and I did this the last time I ran it, we provide plates and silverware, but if you bring your own stuff from home, then we keep the garbage down, and it's better for the environment if you bring like a real plate and silverware and take it home and wash it. You don't have to, but I like the idea.
Great. And if people want to help out and help set up, can they arrive a little bit earlier to help set up and things? Because we'll have some picnic tables and things to rearrange, and the club will want to rearrange the clubhouse a little bit, things like that, set up the grills, things like that.
Oh, that's That's the other thing we're doing different this year. In the past, we've had somebody man the grill for a couple of hours, and that's just too much. So what we're going to do is we will get the first push of meat off the grill so that everybody can eat. If you want seconds, we're going to leave it so you can burn your own food.
Do we have anyone in mind who will be able to help with the growth?
Thank you. Thank you, Kevin.
Last year I was happy to turn hot dogs, but
Yeah.
hamburgers I don't put.
Well, I'm thinking about cheating this year. In the past, I bought raw brats and cooked them in beer, and I'm thinking about buying cooked brats.
Good.
Yeah.
All right, yeah, very good. Yeah, and if again, yeah, if you think you'd like to help out, it doesn't hurt to show up a little early. I think last year we had a couple people show up early and help out with the grills, and we got the grills going and everything. Yes, Jack, did you? No. Okay. All right, and as long as I'm back here, the next item on the announcement list, Jurgen, would you like to talk about membership renewals? I will go in the way back part of the room.
Thanks, because I got confused or I got distracted when somebody gave me cash, gave me $80 and I gave $11 in carry. Thank you. And are either George or Christopher Timberlake here? Okay. I will be here afterwards if you haven't already given me money. I love money. I'm sorry, the club loves money. So I'll be around for a little while after the show to accept your money. Other than that, we're 154 members.
154 memberships. That's remarkable.
155. Somebody else is going to join me.
Oh yeah, that's right. All right, thank you very much, Jurgen. Any questions about membership renewals? Again, yes, there is an option to join the AL, which is just a little bit extra money, and if you don't renew your AL, it'll expire at the end of June in 2026, and then if you do renew, then that membership for the AL will expire the following June in 2027. Which is the tricky, interesting thing since their fiscal year is different than ours. I'm just going to plug this microphone back on here a second. All right. Where was I? We covered the picnic. We covered membership renewals. All right. The other thing that's coming up that's really big is on Friday, October 3rd at 7 p.m. We are having our 2025 Moon over Monona Terrace show. So I just sent some announcements out about that on Sunday, and since then, a few people have gotten back to me and said that they want to volunteer. We are looking for a lot of help because this is one of the biggest star parties in the region, and we're interested in anyone who would like to. I think we're good. We're all set at the information table. We're also looking for people if you don't want to bring a telescope or something to run. We're looking for like 4 people to work as ushers, so that way we'll have a list. We'll have a set up list of what telescopes are where and which telescope is looking at what sky target. And a lot of the times people don't realize, hey, I've already looked at the moon for the 15th time in a row. Is there a telescope that isn't showing the moon? So we rely on ushers to help them find, rather than staying in a line too long, just to kind of announce to people, you can go up, if you're an usher, you can go up and ask the telescope operator, what are you looking at right now? And they say, oh, I'm looking at Saturn. And then you can, with a clear and loud voice, say to the people in line, you're on the line for Saturn. This is the line for Saturn if you want to see Saturn. Yes, Carol, do you have a question?
Way of putting a signage up like we talked about last year?
We've discussed with the Monona Terrace people the option of putting up signs, and we've just not been able to come up with a solution that will work for both them and us. So we're just going to try to cope with it as best as we can. And what's Terry?
Brian Force is asking, would there be more interest in visual observing or live imaging?
We would like to have a little of each, but I think if I remember last time, we'll have about a room for about 8. And that's 2 of the things that we need in addition to the ushers. We will need about we'll have about 8 stations reserved for electronically assisted observing. And each of those stations will have a television monitor that's provided by the terrace. So if any of those people who want to do that sort of thing, if they reply to my message and let me know I want to do electronically assisted astronomy, I will reserve them a spot on the roof, and I will also have them reserve the television monitor. And it's the same for anyone who would like to bring a telescope. Let me know what kind of telescope or binoculars that you plan to bring, and I will reserve an appropriate spot for you on the roof, and then we'll all figure out, we'll figure out which objects everyone wants to do. Because part of the problem with Moon over Monona Terrace with all those guests, some years we've had 1,000, 1,500 guests visit us. And that can create problems if everyone's kind of sitting in a long line with a really huge telescope where the entrance is at. People will have trouble getting inside or outside of the venue. So we'll want to carefully consider which telescope goes where and which spot in the roof, especially for those of us who maybe can't move heavy equipment so far. I want to make sure that they're really close to the freight elevator. And that's the other reason why it's really important to let me know that you want to participate as a telescope operator, because there's this really neat freight elevator that will take you right from the roof all the way down to the ramp area where we're gonna have up to like 10 or 15 parking spaces reserved for us. And you can go right from the John Nolan Drive right into the area where the loading dock is, unload your equipment on some carts, and go right up from the freight elevator all the way straight up to the roof. So by letting me know that you want to participate, I'll be sure to get you all the instructions of how to do all that and which spot will be reserved for you on the roof. Is there any questions or anything? Oh, yes, Kevin?
Yeah, just a couple of comments. The Monona Terrace people are going to have kid activities there too. They're going to have a number of things for the kids to do. The Lake Cafe will be open also. And for those of you who've never been there before, you don't have to bring your power tanks because they do have electrical outlets there, so you can take advantage of that also.
Yes, they'll have, but don't forget to bring an extension cord just in case, because they might not have extension cords. And another thing, if you're bringing a telescope, especially if it's one where, because it's going to be people of all ages there, and they're going to be thrilled, absolutely thrilled to look through your telescope. Just to be sure to bring a step ladder or a stool or something for someone to stand on, or maybe a nice observing chair if that's handy. For some of the smaller Dobsonians, it's sometimes it's a lot more comfortable to look through, when you're sitting rather than standing. So keep all that in mind. Any more questions? Yes.
Not having been to the event yet, how badly is the place lit?
Oh, yeah, that's a great question. He's asking what is going to be the lighting situation up on the roof. They've been very good at switching off all of the main lights and things, and it's one reason why we're going to have all the electronically assisted astronomy folks in an area close, because there's also going to be a presentation area where there'll be lectures throughout the evening, and there will be a nice big projection screen. So we're going to try to keep all of that blue light away from the dark sky visual observing area. And then when the whole thing is over, then all those lights will come right back on, and it'll make tear down all the easier. Oh, yes, a question?
Yeah, these different telescopes, you usually have one target per telescope.
Yeah, I think in the past it's worked out where we'll have 1 or 2 targets per telescope, because the line, people just keep on coming. If you're looking at Saturn, or you're looking at the moon, or another object, say the wild duck cluster, there will just be a constant line of people who are just going to be interested to see what you have, and that's part of the trick, is we don't want everyone to see. No one wants to see the moon 10 times. So, yes, Kevin.
Something else we should change.
Sometimes it can be iffy in terms of the cloud cover and you're shooting holes, so that can make people move around a little bit. One of the things we have to think about too is if the weather is clouded up, we might still be out on the rooftop just doing telescope demonstrations. And for the people that are doing electronically assisted astronomy, generally it's good to have a file of previous objects that you've, a gallery of things that you've imaged, and so you can show up on the screen. Even if, and we did that last time when it was fairly cloudy and you couldn't get good targets. If it rains, we will move inside to the ballroom and set up a few telescopes for telescope demonstrations and still do the electronically assisted images down there too. And so we still have a plan for moon under Monona if moon over Monona doesn't work.
Yeah, so just think of what if you if you would like to help us out in case we do an indoor show. Just have an idea. Maybe you come up with an idea of what your plan B might be. So lots of fun things, and we've done that many times, and it's worked out really well. So yeah, be sure to contact me if you would like to participate. All right, we're running out of time. John, would you like to say something about next month's presentation and then introduce our guest speaker tonight?
Sam, I warned you that one of the microphones was bad. We have the bad one. Hopefully you have the good one. Next month, the October meeting, we will have as our guest speaker, the president of the Astronomical League, a man named Chuck Allen. Chuck, we think he's coming to us from like Louisville or something like that. So this is a person who is traveling a great distance to talk to us. So the Astronomical League is a great group. Chuck is going to do a presentation that involves some audience participation. He has to be here an hour early to set up some of his activities. Come back next month. It'll be fun. Tonight, I am very happy to introduce a speaker that I've been waiting some time to get. Sam Warfel is a undergraduate at the University of Wisconsin. He's an astronomy-physics major, but he is, more importantly for us tonight, he's vice president of the Astronomy Club on campus, and he is also a fanatical aurora chaser and photographer. And Sam is going to let us in on some of the secrets of how he does what he does. So please give a warm welcome to Sam Warfel.
Thank you very much. Test 1, 2, 3. How's that sound? Can you hear me? Cool. I'm so excited I get to talk about the Aurora to a whole bunch of people that were described to me as certified nerds. So I think that will be the perfect first, I'll go through some backstory of my journey discovering the Aurora. The Aurora is gorgeous, often described as one of the natural wonders of the world. So, of course, I always wanted to see it someday, ever since I first knew it existed. I grew up in central Illinois, and I just always assumed you had to be basically at the North Pole to see the Aurora. This is now my photo. I haven't been up there yet. I definitely hope to. I moved to Madison after high school, and I saw in the news that the Aurora might be visible. This immediately captivated me. I had no idea you could ever see it right here at home. By the way, never use this method for Aurora chasing. I went out and didn't see anything. The hoped-for event never materialized, as is often the case. But this was the spark that lit the fire, and I was intrigued. This was solar minimum, so there was lots of quiet time, not a lot of strong aurora going on. I used this time to learn all about the aurora, as clearly there was a lot more here going on than the news articles that I had already found to be useless were letting on. Most of this learning was self-taught, mostly gained from interacting with experienced aurora chasers and space weather enthusiasts, primarily in the Michigan Aurora Chasers Facebook group and their Brain Trust, and the community forums for spaceweatherlive.com. I'll be mentioning both of these more in the rest of the talk. They were instrumental in my journey about learning more about geomagnetism and space weather. It was not until almost 2 years later, in November 2021, that I got Aurora in a photo for the first time. I know, super impressive. Pretty lame, but it was progress. My friend Matt got much better pictures later that night, and I was determined not to give up. I also got violently ill on the way home from that, so it was just generally a mixed bag of an experience. But that means I had nowhere else to go but up. In September of the following year, I managed to take some decent pictures, and technically saw it naked eye, although it just appeared as a dim gray glow. I was definitely left still wanting more. Before and in between these mildly successful chases, I had many less successful ones as well, some even worse than the pictures above. One memorable experience saw Matt and I at Indian Lake County Park sitting in the shelter during a pouring rainstorm. We did not see the aurora that night. One other time, I think it was the bottom right picture there, we did technically catch it. You can kind of see it there. The picture's out of focus if you zoom in, so that's why it's small. But that night didn't go without a hitch either, because when I went to leave, turned out my car was dead, and Matt had to jumpstart me. And it was a Prius. It took me quite a while to figure out how to do it, because there's not a battery in the normal place, and it took me a bit to figure out. I've since purchased a portable jump starter in case I am found at a remote location someplace without anybody around. That got me thinking about that. But aurora chasing from southern Wisconsin is a tricky thing, and a lot of luck can be involved sometimes. All this is to say that you shouldn't feel bad if you go out once, or even a couple of times, and you don't see it. It doesn't mean you're bad at it. It just means you're in good company while we all wait for the proverbial stars to align. Like they did for me at my next aurora. In February of 2023, I finally enjoyed a really good show. Not Madison, as you might have guessed in the picture. This is in the UP of Michigan, looking over Lake Superior. A much better location, to be honest. This was clearly naked eye visible, although the colors still remained but a hint. I could see most of the pillars distinctly to the eye and the swirling bands down there, and I could watch them move and dance in real time. Even get a hint of the reflections on the lake. Color, our eyes do not do very well with color at night, as visual astronomers are aware. So I didn't see much color, just a hint in the brightest green places, and I thought I saw a sort of a reddish haze up there, although so faint that I couldn't convince myself that it was real. And later on that spring, back in Madison, I was able to see the two spring G4 storms in March and April, both around the 23rd of each month and spaced roughly a month apart from each other and the previous one in February. It was an entertaining spring. Both of those experiences were similar to the previous one up on Lake Superior, with lots of naked eye visible movement and detail, not a ton of color. That top one actually was the first time I saw pulsating aurora, which is really neat. If you haven't seen it before, there's patches of aurora throughout the sky, and then the light sort of sweeps through them as they flash on and off in sync with each other. It's like waves of light rushing overhead every couple seconds or so. Extremely unusual compared to most types of aurora. The one thing about having such a good spring was that all of these strong storms made me what Matt and I call geomagnetically spoiled. When I was just getting started, I would go out and chase every dim little blip that we could possibly hope to see. But after these amazing shows, I became much less motivated to get out and chase the little ones. It makes me sad, but I think it's partly just a reality of living in a city that makes it fairly labor intensive to get out and chase, especially when the storms are small and dim and I have to go well out of town to see them. I have a ton of respect for the folks who go out all the time. They've caught the aurora many times over, as many as I have. But from around this time going forward, I tended more to only chase the really strong storms, or when I happen to be camping up north. But speaking of really strong storms, I'm sure many of you are familiar with the great storm of May 11th, 2024. It was pretty indescribable. I also saw the October 11th, 2024 storm when I happened to be involved in an astronomy event on campus. At first, I was disappointed that I wasn't able to go out and see it from a dark site, but this turned out okay since it was actually strong enough to be naked eye visible on campus, and I was able to photograph it there. I had toyed with the idea of staying in town to photograph the aurora over interesting foregrounds with buildings like that, but I'd always been too scared to try risking one of these rare, really good storms by staying in town. Thought, what if I miss it? And then I've lost a rare opportunity. But this turned out perfectly, since I had to stay in town anyway, and it worked out lovely. In August of this year, I saw this brief but lovely display back on Lake Superior. A short substorm under KP3 or 4 type conditions. I was able to see the pillars distinctly to the naked eye. Sorry it's not Madison area, but what can I say? Superior is superior. And most recently, I saw a small display back here in the Madison area on the 1st of this month. This was a KP6 or 7 G2 or G3 level storm from a CME impact. It was originally hoped to be a better show, but this brief substorm immediately after dark turned out to be all we got due to how the data timed out. That brings me up to the present. I've only caught it these 2 times in 2025, actually. I'm a bit embarrassed to admit. All in all, over the last 5 or so years that I've been chasing with more or less knowledge and motivation, I've caught it roughly 15 times from the southern Wisconsin area, and a handful more from up in the Northwoods and the UP. Some people have a far better record than me, but for living in town down here in the South, having a busy class schedule, etc., I only chase when it catches my fancy to do so. It's just a hobby, after all, but one that brings me joy, just like astronomy is for many of you folks. It's been a lovely hobby, one that has gotten me out under the stars many times. Those of you who enjoy visual astronomy at dark sites understand this well. Or it can be very relaxing. No equipment needed to view. You can just sit back, relax, and enjoy the show. It can be stressful trying to figure out when it's happening, find a good place, and see if it's there. But when it all comes together, it's one of the most beautiful sights on Earth. That brings me to the second part of my talk, the nitty-gritty on how you can see it for yourself. The hardest part is knowing when to look. The most important thing I can say is what not to do. That's this. Do not use mainstream news to tell you when to go out aurora chasing. Yes, they are sometimes right. I think a lot of people saw it May 11th because the news said so, but they are more often wrong than right. Forecast information is often incorrectly interpreted and not up to date. Sometimes it will even be as bad as being published the day after a strong aurora the night before, suggesting that it will happen again the following night, when it totally does not, leading to a lot of disappointment. There are much better methods we can use to get our information. Also, I need to add to this, do not pay attention to AI-generated Facebook pages like this garbage. They are totally ridiculous and could not be more inaccurate. They're usually fairly easy to spot, these wild AI images and crazy unrelated names. Surprise, surprise, nothing even remotely resembling a storm was happening when that was posted, or actually in that entire week. In a moment, I will share the Facebook pages of some actual experts who are a far better source of information. Bottom line, don't rely on the news and only the news. If you see an aurora headline that reminds you to check the real forecast pages, great, but don't let it be your only guide for when to chase. What should you do instead? The easiest source is reliable, trustworthy Facebook pages and groups. Here's what I would recommend for the best for our area at the moment. Obviously, we have the MAS group. There are several people here who share reliable information when the aurora is expected to be particularly strong and visible in our area. I try to post in there as well when I'm out. The Northern Lights of Wisconsin group is the preeminent aurora group in Wisconsin. They share reliable information and live sighting photos pretty much whenever the aurora is out. The Michigan Aurora Chasers group is also fantastic. They're Michigan-based, but everything there correlates to here straight across the pond. Vincent Ledvina is a very knowledgeable aurora expert who frequently shares updates on solar and auroral activity. He has both Facebook and Instagram and a website. I highly recommend following him. He's based in Fairbanks, Alaska now, lucky fellow, but he's actually from Wisconsin. Mary Beth Kaczynski is an extremely talented photographer and space weather analyst, and the page Space Weather Unplugged, run by her and Christian Harris, is a good source of solar and aurora updates. There are a good handful of other quality sources on Facebook, but I would highlight these as the best for beginners in Wisconsin. And don't worry, these aren't more AI-generated pages. They're all real people. I checked. They're super nice people, too. Along with trustworthy Facebook pages, the second source I recommend is spaceweatherlive.com. There are some other aurora-centered websites out there, but most are pretty rubbish compared to Space Weather Live. SWL has pretty much all the relevant information. The only difficulty is it can be a bit of a learning curve. I'll spend much of the remainder of my talk digging into that for you. They also have a very well-designed mobile app for easy reference when out chasing. Everything I will discuss related to Space Weather Live applies both to the website and the app. They're pretty much identical, so you can use whichever one is easiest and most convenient for you. Like live sightings from Facebook groups, webcams can be helpful since they are always on. There's a nice list of them on Vincent Ledvina's website, theauroraguy.com. It's under the Resources tab, or you can just Google Vincent Ledvina webcams. The ones in the Midwest and areas north of us will be the most helpful to find out when the aurora may be strengthening or coming our way. The IORL cams are favorites of Wisconsin and Michigan chasers in particular. Before we jump into forecasting, let me quickly address the where part of the question. You all are pretty good at finding dark spots in the country. That also works very well for aurora. All the normal considerations like light pollution, moonlight, wildfire smoke, and of course the clouds all affect the aurora the same way they do with astronomy. A very strong aurora during a strong geomagnetic storm can overpower a lot of that. That's how it was visible anywhere in Madison on May 11th or October 10th, for example. But on the weaker ones, you want as dark and good of conditions as you can get. The only difference from normal astronomy is the sky low on the northern horizon can be more important than overhead. So you want to be someplace without any cities north of you. The darkness quality of the skies north of you can be more important than that of where you are. For example, from Madison, it's better to head north, west, or east, as going south, you'll just be looking back at Madison. Unfortunately, this means Yana isn't ideal for those weaker shows, as far as I can tell. Some spots I recommend are Indian Lake County Park and Brigham County Park. Closer to town, Pheasant Branch Conservancy can work, just somewhat brighter skies. If the storm is at least moderately strong, along the south shore of Lake Mendota can work, such as the Observatory Drive overlook or anywhere along the Lakeshore Preserve and Picnic Point. I've seen some lovely photos of it over the Union Chairs. The above image is a KP7 or G3 storm from Indian Lake under challenging viewing conditions. And of course, if it's an extreme storm, then pretty much anywhere works. Do you need to go northwards? Depends. Obviously, the aurora is better further north, but it doesn't make a huge difference if we're just talking about going an hour or two. Within that distance, I prioritize finding dark northern skies. That'll make a bigger difference for you than going straight north. For us, that can mean going northwest or west into the heart of the driftless region. If you go further, like up to the Northwoods, at least as far as, say, Minocqua, around the 45th parallel or higher, or to Lake Superior, that can make a big difference in aurora visibility for sure. That's both due to being further north and the much better sky conditions, especially if your north view is the lake. The south shore of Superior is hard to beat in this part of the country, in my opinion. So if you're up there already, or you can go up there, awesome. But we can see it down here too. It just takes a stronger storm. My talk will focus mainly on what we need to see it down here in southern Wisconsin. If where is settled, how do we know the when? Especially if we want to know ahead of time, before we start to see live sighting photos on the Facebook groups. That's aurora forecasting, and is both perhaps the most important part of the chaser's job and the most difficult. There's way more here than I could ever cover in one talk, and I'm still learning, but I will try to hit the highlights. First, let's briefly cover some types of solar activity. The sun is the source of all of our aurora, and certain events on the sun can lead to the strong aurora displays that give us a good show down here in southern Wisconsin. Learning what those events are and how to monitor them can be helpful for guessing when aurora is likely to appear. If we go to Space Weather Live and hit the Solar Activity tab at the top of the main page, it takes us to this page, where we can monitor for exciting solar events. The sun often has these sunspots. You may be familiar with them. Areas of concentrated magnetic fields. The amount, size, and complexity of the spots follows a roughly 11-year cycle, of which we are currently just past a maximum phase. That's why the aurora has been so good recently. Sunspots are the source of our strongest auroras, so the aurora activity follows that 11-year cycle. We can monitor the current sunspots here. Basically, keep an eye out for really big ones, or ones with red labels in the table below, so they're most likely to do the things we want. Solar flares that launch coronal mass ejections. Here's where we watch for those flares. They show up as bright spots in the image, and spikes in the graph of the X-ray flux below. For example, there's an M1 flare in progress when this screenshot was taken. We can see the bright spot indicating the flare, It's from a region of the sun that is not directly facing Earth, but not right on the edge either. So there's a chance if it launched a coronal mass ejection, or CME, that it could be directed toward Earth. Ideally, we'd want to see them in the center of the sun, directly facing Earth. Even if you see a big flare, like an X-class flare, it's important to verify if it launched a CME or not, as many do not. And if it did, whether it's directed toward Earth or not, before you start to get excited about aurora chances. This imagery shows CMEs when they launch and is used to judge their strength and get estimates for direction and travel speed. This all is pretty complicated. Analyzing solar activity is definitely one of those things I recommend checking the information put out by the aforementioned Facebook groups and pages to help you break it all down. To get good aurora, we need very specific sets of circumstances that are pretty rare, so it's important not to jump to conclusions. One nice thing is that when something is launched from the sun, it typically takes a couple days to reach Earth. This is one of the biggest sources of the lead time we see in the forecasts. Other than that, we are pretty much flying blind until an hour before the aurora happens, at best. I'll explain that later. Okay, jumping back over to the auroral activity side of the site, my preferred home base for aurora chasing data. Other sites like spaceweather.com can be good for a news flash, but use Spaceweather Live for forecasting and nowcasting real-time data. If you're really enthusiastic, you might want to look into the Glendale Aurora app, but I'm not experienced enough on that one to teach it. But I will say many people find it helpful. Let's talk about the KP index. If you've heard of any aurora-related data metrics, you've probably heard about the KP index. Unfortunately, it is not often explained well. The KP index, standing for planetary K-index, is a global 3-hour average of ground-based magnetometer data. This has important implications for us aurora starters. To get started, KP is a 1 through 9 number scale where 1 is very low activity. During KP1, the aurora would be confined to well above the Arctic Circle, and 9 is a severe storm, such as May 11th last year. The KP is considered to be at storm levels when it is at 5 or higher. KP5 is the same as a G1 storm, KP6 is a G2, and so on up to KP9 or G5. You might see both methods of referring to storms, but they just mean the same thing. What the KP index is good for: estimating the overall strength of a storm. For example, this is the 3-day KP forecast drawn from NOAA's Space Weather Prediction Center. Here we can easily see if there is any noteworthy activity predicted. Looks like the strongest predicted is KP4-, or 3.66, so not very exciting. No geomagnetic storms, KP5 or higher, are predicted at this time. That's typically at least what we would need to see it down here in Madison. But this is a good place to look to see if there's anything coming up that we should keep our eyes on. Sometimes we get unexpected activity that wasn't forecasted, but often it is. What the KP index is not good for: live data. Because this is a global 3-hour average, it does not tell you what the aurora is doing where you are at the time you look. Here's why that's a problem. If you saw a KP7 G3 storm was predicted for tonight in the KP index forecast down below, and you waited for the big KP index dial to ramp up before you go out looking, you are very likely to miss the show. The aurora can ramp up and fade very quickly, a matter of minutes. And because the KP index is a 3-hour average, the KP might not go up until an hour or more after the aurora kicks off, and by then it may have faded away. So if you only go out then, it could be too late. So what do we need instead? The aurora chasing essentials for me are: nothing beats ground truth live sighting from our trusty Facebook groups. After that, we use the real-time solar wind data, or RTSW, hemispheric power, or HP, and magnetometers. I'll go through each of these. Real-time solar wind, or RTSW. You can think of this as the driver behind the aurora, the stream of charged particles let off by the sun that interact with the Earth's magnetic field to cause aurora. So understanding what the solar wind is doing in real time can be a big help to knowing how the aurora should behave now and in the near future. You can go very deep on this, but here's an ultra quick and simple to get you a foothold. Speed. Higher is better. Ideally, we'd want to see 600 plus to see the aurora down here. Density. A measure of the density of the charged particles in the solar wind This is less impactful for aurora than speed, so don't be concerned if this graph isn't high. However, it's generally believed that high density can cause especially vivid or colorful aurora, so that can be something to keep an eye out for. Also, this data stream in particular, but all four of these, can see big random spikes or places where the data drops out. Our monitoring craft are very old and somewhat unreliable. New ones are on the way, but until then, you might see some problems with this data. If you see a big spike up and it immediately dives back down, that's probably a giveaway that it was just a glitch and there's not actually anything exciting going on. BT, which stands for B total. This is the total strength of the interplanetary electromagnetic field that is carried along by the solar wind. We do want this to be pretty high, mostly because of this next component. BZ, the most important one, the gatekeeper for aurora, as the Michigan Aurora Chasers term it. This is the z-axis component of the IMF. The others, the BX and the BY, don't matter nearly as much. We need a steady southward BZ to charge up the best aurora, ideally more than -15 for an hour or more. This is because if the BZ is northward, the IMF does not connect with Earth's magnetic field, and the solar wind simply deflects around Earth. If the field is southward, the IMF links up with Earth's field, and charged particles can be accumulated, and sent spiraling into the atmosphere along the magnetic field lines in the polar regions, driving aurora. Since the BZ is a component of the BT, BZ can never exceed the strength of the BT and will usually be less than it. But we can use the BT to show us the possibility for how strong the BZ could become. For example, if the BZ is weak, not good for aurora, like it is in this picture, 1.27 northward, not very strong and northward. But the BT is strong, like 20-ish, say, then there's a chance the BZ could become much stronger, theoretically up to 20 nanoteslas southward, but that doesn't mean it necessarily will. And on the flip side, if the BT is weak, down at 1 or 2, then there's no chance for strong BZ unless it increases. So even if the BZ is northward, you can get some hope if the BT is still strong. We can hope that it could turn around and go southward still. All of these graphs will turn yellow, orange, and red as the data gets better for aurora. So if you see everything green on here, like it is when this screenshot was taken, probably not ideal. If you see red, especially in the background of the BZ graph and in the speed graph, things might be getting exciting. One note, it's hard to give specific numbers for how much of any given metric we need to see the aurora at our location because all of these work in concert with each other. A very high value in one can help compensate for a low value in another one, etc. The most important one is BZ, though. If BZ is fixed steadily northward for a long period of time, it is unlikely we will get anything good, no matter how high the others may be, within reason. This is why that storm back on the first of the month turned out to be a bit of a disappointment. Right around sunset, when I got out there, the BZ went north and stayed that way for turned out the entire rest of the night. So that brief little initial thing that we got left over from before was all, and after that it quieted down. Let me briefly explain this line here, labeled Earth on the graphs. This data is not measured around Earth, but at the Earth-Sun Lagrange point L1, which, if you're not familiar with it, is a point in space located about 1.5 million kilometers away from Earth in the direction of the sun. What this means is it sees what we will get before we do, which is super useful, as it gives us a bit of a lead time to go chase. If we see a big coronal mass ejection hit, which would look like a big spike or step up in most or all of these plots, that gives us a little time to get out of town to a dark site or whatnot. The exact amount of the lead time depends on the speed of the solar wind at any given time, naturally, as that determines how fast the wind will cover the L1 Earth distance. The exact lead time is calculated and displayed here up at the top, which is quite handy. So this line labeled Earth just shows the data points that are currently impacting Earth. Everything to the left of this line is past Earth, behind us. Everything to the right is yet to get here in the future. So if you see something exciting appear in this graph, you could have around an hour to grab your stuff and head out the door. It's very handy. That's a lot to digest. If only there was something to do it for you. But wait, there is. The Ovation Aurora model, specifically the hemispheric power, or HP index. It digests all that real-time solar wind data into one overall aurora strength number. It's better than KP because it updates basically continuously. For the Madison area, we want to see it in the 60s or so to capture aurora on camera from a dark site. For naked eye visibility, we probably need around 150 at a dark site, 200 in the city, and those numbers assume perfect viewing conditions. However, the HP still doesn't capture substorms, one of the most impactful factors for aurora viewing. I said the two problems with KP were it's not real time and it's not local. The hemispheric power fixes the not real time problem. It does not solve the local problem. As you can see, you have one whole number for the northern hemisphere and another one for the southern hemisphere. Substorms are where the local phenomenon comes into play. What is a substorm? A substorm is like a mini aurora storm, or an aurora explosion, not to be confused with a geomagnetic storm, which is an extended period of high KP, generally extended, doesn't have to be, indicating generally highly active conditions. Simply put, it's when the aurora can go from mediocre to wow in a matter of minutes. Obviously, predicting this is of great interest. Unfortunately, substorms are extremely complex and cannot be forecasted with 100% accuracy. Here's an example. Both of these images were taken during the same KP levels. If it was a geomagnetic storm, they would both fall under the time that is considered the storm. The one on the left was taken before the substorm, and the one on the right was taken a matter of minutes later, after a substorm began. As you can see, it makes a huge difference in aurora visibility. Further south, it would be the difference between seeing it and not seeing it at all. So substorms are extremely important. How do we detect them? We do have some tools. Generally, the most useful are the GOES magnetometers, which can be found here on Space Weather Live by clicking on Aurora Activity from the top menu, or side menu if you're in the app, hitting the magnetometers page and scrolling all the way to the bottom. This general sinusoidal wave shape is the norm for this graph. This is caused by the geostationary GOES satellite passing into and out of the Earth's magnetotail over the course of a day. This is a different source for the plot, but the same data. The sudden step-up-like jumps, indicated by the green arrows, have a good chance of indicating a substorm onset. So if you see this jump, keep your eyes peeled. Please note there is no lead time like on the solar wind graphs because this data comes from Earth orbit. This is pretty much instant. Unfortunately, it doesn't give you any prediction time to go out and chase. Here's my personal philosophy about chasing substorms. If you live someplace dark and far north, so you can walk out the back door and check on the aurora within minutes, great. You can wait for a substorm to occur before going out. But for those of us that live in the middle of the city, down here in southern Wisconsin, it takes too long to get someplace where we can see them. So I think it's best to just go out at the start of the night when conditions are looking promising, i.e. strong geomagnetic storming is in progress or believed to be imminent, and stay out for most of the night. That way, if substorms occur, they usually do, you'll see them. If they don't, well, you didn't miss anything. Jumping back to this example. I go out when I know, based on data analysis and live sightings, that the aurora only looks like the boring one on the left, because I know there's a good chance that it could substorm and look like the one on the right. I want to be out when that happens, because there's not really any advanced warning. I can't wait for the substorm to start before I leave my house. They typically don't last long enough for me to see them if I do that. If you don't want to miss aurora, you need to stay out all night. Many times it can flare up in the pre-dawn hours, or be rocking right after dark and then die out. The only way to be sure not to miss it is to be out as long as it's dark. That being said, I admit that May 11th is the only time I've stayed out all night for aurora. I usually go to bed after I've seen enough to be satisfied, but I've missed some doing that too. So make your own choice about what's most important. Please note that most data in the aurora and solar activity world is given in UTC, including on Space Weather Live by default. However, there's a neat feature that's a bit hidden. There's this UTC clock up here in the corner circled in red. If you hit that, then it will change to your local time zone. And more importantly, the time on all the graphs, hemispheric power, solar wind, and IMF, will also change to your local time. I don't use this a ton because for me, mostly the relative time is more important than the absolute time, but you might find it useful. On the app version, the clock to hit is a little floating tab in the bottom right corner. Well, this is a bit overwhelming. Something you may find useful is the Help tab or page on Space Weather Live. It's just up here, or in the side menu on the app. The list of acronyms and abbreviations is great. There's an awful lot of them in this field. The main Help page also offers a lengthy overview of solar and geomagnetic data. If you want to really dig into all that stuff, you might appreciate that, but it is quite verbose. In a similar vein, if you're wondering about something found on the site specifically, look for these I buttons. If you move your cursor over them, it will display a little pop-up window explaining what that item is or how it works. A great feature to have on a fairly complex site like this. If all this seems too complicated, let the experts do it for you. Pages such as Vincent's, or the admins and group experts in groups like Northern Lights of Wisconsin and Michigan Aurora Chasers, will post forecasts and recommendations for when things might be interesting and you should go out chasing, as well as the live sighting alerts, of course. Here's another useful thing I want to point out. It is the archive on Space Weather Live, which allows you to look up the Aurora data for any past date. Please note it takes a day or two for some data to show up here, and the official KP is only finalized and added in twice a month. But this can be useful to look up the data for, say, a strong past storm. For example, what was the solar wind and IMF data like for May 11th? I navigated to the corresponding entry, and here we can see the large CME impact, the speed almost immediately jumping to 700 or so, which is high but not extreme. We've had higher this cycle, actually. Density is also high, but it was the IMF that really stole, or rather made, the show. You can see the BZ was mostly south here for this first part of the storm, reaching as low as -50 and remaining below -25 for hours. This continued well over the next day as well, which is why this was such an extreme storm. I have a video on the process of detailing looking up Aurora data in the archive on my YouTube channel, going through it step by step, if anyone wants a more detailed guide. If you have a specific date in particular that you'd like to see the data from, let me know after I'm done and we can look that up for you. Let me talk briefly about gear and photography techniques. Most of it is very similar to wide-angle Milky Way astrophotography, so if you're familiar with that, you probably know most of this already. Using an interchangeable lens camera, you want as wide and fast a lens as possible. I started on a kit lens that was 18mm at f3.5. That got me going, but was a bit slow. Now I use a 16mm f2.8, which is decent. Something like the Sigma 14mm f1.4 are often the gold standard, but I certainly don't have the budget for that. No need for any kind of star tracking here. A fixed tripod is all you need, or really anything to keep the camera still. An intervalometer is nice for time lapses. You just take a series of pictures. And you may want a dew heater band or hand warmers attached to the lens to keep it from fogging or icing. And that can be definitely a problem and very frustrating if you don't find out until later. Don't forget spare batteries for a long night in the cold. They can die quickly. And of course, enough memory card space, especially if you're doing a time lapse with accumulating a lot of pictures. For your camera settings, have the aperture wide open, ISO high but not crazy, whatever you use for normal night shooting. I use ISO 1600, but I have an older DSLR. Modern mirrorless cameras can go much higher, I think to 128,000 or more. But experiment, see what gives you good results. Exposure time depends on how bright and fast moving the aurora is. If your exposure is too long, it will blur out the detail in the aurora and make it look kind of mushy. So generally, you want as short an exposure as you can get away with still letting in enough light to get a good picture. The two above were very strong shows, so those were only several seconds long. On May 11th, I went down to just a couple seconds with overhead corona. If you have a faster lens, you can drop it a couple seconds. If you have a slow one, you may need to extend it some. Both of these shots were 4 or 5 panel panoramas that I stitched in the processing phase using Adobe Lightroom, as these aurora just got too big to fit in my view. And speaking of processing, that's an important part of the photography. You can think of it as analogous to developing an image from film. The first and most important step is to have your camera set to save its photos in RAW format, not JPEG. This will give you much more flexibility down the road in deciding how you want the image to look, and gives a higher quality result with less noise in my experience. Here's an image that has been processed or edited, and here's that same image as it appeared in RAW format straight out of the camera. This is actually more like how it appeared to the naked eye for this particular very weak aurora. As you can see, the editing difference makes a massive, editing phase makes a massive difference in how visible the aurora is in the pictures. Unfortunately, I can't really give specific advice on how to process these photos. Just play around in a capable program like Lightroom, Photoshop, or really whatever you have, until you find things you like. I mostly live by trial and error rather than a formal process. Also, during a very strong storm, when the aurora is much brighter, not like this one, you will find the editing to be much more straightforward because the signal from the aurora is simply many times better. The dimmer the aurora, the harder it will be to pull it out. And yes, you can do this with modern camera phones too. Most of them can do an impressive job. My friend Matt took these photos with his Samsung S23, I believe. Maybe it was an S24. Recent iPhones achieve similar results. It blows me away how far smartphone cameras have come. The most important thing is to keep the camera still, ideally with a tripod, but in a pinch, propping it on a post, car, a rock, or the ground can work, whatever holds it still. One more thing I'd like to point out is a handy feature on Space Weather Live. If I figure out how to get over there. Yes. They have free alerts, which is one of the most valuable things about the website. What is it? There's supposed to be a little floating bell down here in the corner in the desktop website. But most importantly, if you go in the app at the menu, that's a community alerts. I believe that's different. Most importantly, in the app, there's an option for alerts, which are under their side menu. And those are extremely useful because you can get push notifications sent directly to your phone when the aurora is getting good. You'll find some other websites like spaceweather.com advertise services like this. They can charge upwards of $100 a year for this service. Space Live does them for free. It has many of the exact same alerts and even some that the $100 spaceweather.com ones don't have. Some of the most useful are the CME impact alerts. The automated filters can detect many CMEs when they arrive and send you a notification, or you can set for a given hemispheric power or KP level just to receive an alert. And you can also get them for solar activity like solar flares. I'll get back to my presentation. Oh, I quit it. Well, that brings me to the end of my formal prepared talk segment. If you have questions, I would be happy to answer them. We can also look at Space Weather Live, and I can answer any questions that you may have about that.
If anybody has a question for Sam, raise your hand and wait till I get to you with the microphone.
So you know about the Space Weather Prediction Center, they have the 30-minute forecast. Is that really something you look at?
The text-based 30-minute forecast, where it gives you,
like it's the national.
yes, that's the Ovation Aurora model that I spoke of related to the hemispheric power. That green oval shows, that's just a visual representation of that hemispheric power strength. The higher the hemispheric power, the larger, brighter, and further south that oval will extend. I find the hemispheric power to be a little bit more straightforward to look at because you can just get one number rather than trying to zoom in on the image and see how far down that oval gets. But they are the same product under the hood. And you can get that information and most of the data actually either on Space Weather Live or directly from SWPC. And Space Weather Live pulls from SWPC, so it's the same data wherever you get it. SWPC can actually be a couple minutes ahead, actually. So if you're really waiting for something exciting, then you might try there. But it'll come through Space Weather Live shortly.
Great Lakes Aurora Hunters.
Great Lakes Aurora Hunters is another good Facebook page.
Indeed, they have some extremely knowledgeable people there that post very good regular updates.
Anybody?
Thank you. That was a really excellent lecture, and I learned some things and good hints. And I have one question though. Well, actually, I have one comment.
You're talking about how we could save some money like on space weather, live getting alerts. If you go to Amazon, you can actually get for your cell phone a tripod, a holder, and a little clicker. Yeah,
Neat.
for $10.
My friend Matt
Totally
has
adequate.
something similar.
Yeah.
Although his does have a very bright LED light on the remote, so that might be something you want to check for and put a piece of tape before you go out, because it can be a little irritating.
Hi, do you have any feeling for how often a storm of the strength of May 11th occurs?
Great question.
Or is there not really much of a typical interval?
That question is highly time dependent in terms of years because we go through this 11-year solar cycle. If actually right down here we have a graph that should, yes, answer your question exactly. So you can see here the number of days with geomagnetic storming, and break it down by category. You specifically, it's extremely counterintuitive to have my cursor up there. You were specifically asking about storms on the scale of May 11th. So if we turn off these others, now it's showing just the G5 extreme geomagnetic storms. You can see they happen in this roughly periodic nature every 11 years as we go through the peaks. We've only had one this solar cycle so far. Previous solar cycle had a couple. The ones before that were even stronger. So for a storm the strength of May 11th, I think it's a fairly safe bet to estimate a couple per solar cycle every 11 years. The weaker ones like G4 storms can be almost as good, and we get a fair amount more of those. So that's about the frequency that you can expect.
You just made me think about maybe you have this data. About 20 some odd years ago, 24 years ago, I went out to see the Perseid meteor shower, and somebody came and said, "No, don't bother. It's cloudy," to my house. And I says, "That doesn't really look like clouds to me." We went out, and the entire night, this is the night of the Perseid, peak of the Perseid meteor shower, there were Aurora Borealis that were overhead and even touched the southern horizon. They covered the entire sky for the entire night.
There were some
What night was
phenomenal
it?
storms.
When was that? I can't remember. I can't remember. It was the night of the Perseid meteor shower, about 20 some.
2001.
Yeah.
Did you say 2004 or 5?
It was the early to mid 2000s.
We had a number of strong storms during that period. The most famous of them are the Halloween storms of 2003. So that would be some of Perseids. This doesn't break it down by month, does it? I can do a little digging in the archive, and we can look at that if you want. If we can get the year, there should be data for that in the early 2000s. I bet we could find what storm that was. Although things were generally more active back then than they have been recently. So there might be a handful of events that could fit the specific criteria.
Considering that this was going on for the entire night, the Perseid meteor shower was great. The aurora was on the. This was like the most spectacular thing I've ever seen, except perhaps for a total solar eclipse.
Sure.
I mean that there was nothing close to it.
Aurora Summit up in northern Wisconsin last year. The keynote presentation was by Bob King, and he said that the two most spectacular, the two 10 out of 10 night sky sites, sky sites that you can see were a total solar eclipse and a full sky multicolored corona aurora.
Yeah.
I think I remember the auroral display you were talking about, and I kind of related to the display that Lewis and Clark mentioned in their journals. And it's at the time I was following along in the journals. You know, what did they write? 200 years ago, and it was like the day after the their entry of the big auroral display in their journals. So that could be a clue to help narrow down the date for you.
The Carrington event of 1859 isn't a particularly famous one. That's probably the strongest geomagnetic storm that we have recent written records and reliable aurora observations for. It caused a lot of damage to the telegraph grids. Those were the only thing large, made of metal, and extended over very large distances, which means they accumulate electrical currents, caused a lot of fires, and the aurora was visible almost to the equator. People said they could read a newspaper outside at night by the light. If something of that level happened again, now it could do serious damage to power grids and internet infrastructure, and potentially a lot of damage to satellites. So we hope something like that doesn't happen. Now we have a lot of monitoring equipment so that we can tell when it's coming and prepare. But there have certainly been exceptionally strong events in history.
You just mentioned an Aurora Summit. Do you want to say a few words about where it is, how often it is, and what the presentations are like?
That's a conference that's held every year, usually in November. Recently, it's been up in the Apostle Islands near Bayfield, Wisconsin. It's put on as an independent venture, but run by a couple of the people who founded some of those Facebook groups that I mentioned, the founder of the Michigan Aurora Chasers, and Dixie, who I know some of you here know. They have seminars from a bunch of people. I actually gave one on Space Weather Live last year. Lots of fascinating people to talk to and learn all kinds of things about the aurora. If the aurora and the weather works out, then we'll go out and see it since we're up north there. Although more often than not, that doesn't work out. But it's an excellent time to meet a whole lot of people that are interested in the aurora and learn all kinds of things. I can, if you're interested, I'd be happy to post to the Madison Astronomical Facebook group some information on that.
There was a comment from YouTube that that it happened last year too during the Perseids aurora at the same time.
I think so. Yeah, I actually missed that one. My job over the summer had me getting up very early and wasn't able to go chase, unfortunately. But I remember people talking about that.
That was also a good one for 2 cents.
Impressive. I didn't remember it got it.
So looking back, using the archives.
Yeah. So you thought 2005? 2005, there was like a kick-ass storm, but that was August 24th. So that would have been too late.
You're certainly right.
August, we're in 2003, right around it. Yeah, so it's like August, this is like August 7th. But yeah, so maybe it was more like 2003.
For that storm, I was at Indian Lake County Park for the Perseids with a group of people, some MAS members, and we forgot all about the Perseids by 9 p.m. The aurora was so phenomenal. I would have to look up my archives, which is my photos, to find out the exact date, but I'm sure one of these is what we're referring to.
I was just curious if you've heard of a type of aurora that was called Steve, and if you know anything about that.
I wrote a paper a couple of years ago on all the various rare kinds of aurora. That's a particular favorite niche of mine. I have not actually caught Steve myself. I seem to, every time it comes out are the couple of nights that I'm not out. But one of these days I will catch it. It's somewhat unusual. Happens further south than the normal aurora oval at times, which is why it can often be seen, comparatively, by folks down here in the mid-latitudes. It sometimes lasts for just a little period, sometimes longer, and it has that distinct appearance of a white ribbon in the sky running east to west. It doesn't move as much as the normal aurora does, and it runs east-west instead of being north-south. It's horizontal, often from horizon to horizon. Quite unusual. It can be mistaken for a cloud or something like that, but it's around.
What is the paper called? What is the paper called?
Oh, I haven't gotten it published yet. I call it the Morphology of Auroral Types and Related Phenomena. I'd be happy to send it to anyone that's interested.
Okay, thank you for your questions. I'm going to turn it back over to Lawrence.
Thank you, John. Well, you'll have to allow me to fiddle around for a second because I've just been absolutely mesmerized by the questions in this topic. This has been a great presentation, and I can't wait to go online and explore keep an eye on some of these tools sometimes. It looks like a lot of fun. And on behalf of Madison Astronomical Society, I would present you like a little this mug with our logo emblazoned on it. Thank you very much, Sam.
Thank you very much for that.
Thank you, Evan. All right, I'm just gonna look at my notes really quick, because this concludes this month's meeting of the Madison Astronomical Society, and we will be back here again on Friday, October 10th at the very same bat time and the very same bat channel. Have a good month, everyone, and it's great seeing you.